So in our previous video, we had a brief idea about what is displacement. A displacement of object M from point A to point B. That is the initial and final position is known as your displacement. This is D. Now, when you talk about velocity, this is velocity. Velocity will be given as, say suppose velocity at this particular point, then the distance that has been covered from a point small a to small b upon the time taken, that is del t, upon del t, this will give you velocity. That is the distance travel at that particular point for a small time interval. This will give you velocity. Now what is average velocity? Average velocity. Let's look at two examples and understand this. Say suppose this is a distance of 10 kilometer and the time taken is 10 hours. So we know that at every instant of time, say suppose in 1 hour it covers 1 kilometer. In 1 hour it covers 1 kilometer. At any point of time we will see that in 1 hour it covers 1 kilometer. So velocity is actually 1 kilometer that has been covered in 1 hour. So the velocity becomes 1 kilometer per hour. So this is simple. Now let's change the scenario. Now this is A and this is B. This is the whole distance. This 10 kilometers is the whole distance. So A goes to C. C is a point somewhere in middle of A and B. Somewhere in middle of A and B there is a point C. So it goes to over here, then it stops for another 10 hours. It stops for another 10 hours. And then it finally comes to position B. So when you talk about the average velocity for someone who is not looking at this whole scenario and you want to tell him how much time does it take, so what you will do is average velocity is the total distance upon total time. Now total distance is 10 kilometer. That we know, total distance was 10 kilometer. It's not changing. That is the total displacement. This is 10. But what about the total time taken? Now from here to travel to here, it takes 10 hours. Now our additional wait time of 10 hours has been added. So now the total time is 10 plus 10 hours, which is equal to 10 by 20 hours, which is equal to kilometer per hour. This is kilometer. So the final speed becomes 0.5 kilometer per hour or 1 by 2 kilometer per hour. So this is its average velocity. Now I think we have an idea as to what is average velocity. Total distance upon total time, that is what is instantaneous velocity. Instantaneous velocity or a constant velocity that has been maintained. So instantaneous velocity is velocity at this particular point, at any point in a given interval of time. So this is what we know as velocity. Now acceleration occurs when there is a force. Now say suppose this body M is moving. Initially it was at rest 0, that is the velocity was 0. But a force is being applied, a force. So because of the application of force, there is a change in velocity. There is a change in velocity with respect to time. First the velocity became, say suppose the velocity became v equals to 1 kilometer per hour. But the force is constantly acting on it. So after that, this velocity will keep on changing. This velocity keeps on changing. That is, the velocity keeps on increasing because the force is pushing this velocity to increase. So that is, it's changing the rate of velocity. Therefore, dv upon dt is equal to acceleration. This is how we can understand the physical meaning of acceleration. Because of force, F is constantly pushing this object M. Therefore, now it will be, say suppose V equals to 1 kilometer per hour. After some time it will be 2 kilometer per hour. After some time it will be 3 kilometer per hour. So the rate of change of velocity is 1 kilometer per hour square. The rate of change is actually 1 kilometer per hour square. So this is what is happening when we apply a force F. Now, acceleration is not always positive. Sometimes our object is moving with a very high speed V and we apply brakes. So what happens then? Application of brakes means to apply a negative force. That is, this is also termed as deceleration. Deceleration. Or a retarding force. Retarding force has been applied. So this is what we mean by deceleration. So now we have an understanding of what is acceleration and what is deceleration, plus also what is velocity. Now these are the physical meaning. Now let's understand this mathematically. Now to understand this mathematically, what you need is your graph. Say this is your x-axis and this is your y-axis. Now, say suppose this is time t. Let's say we measure time in the x-axis and we measure displacement in y-axis. Now let's take this example. Suppose this is a man and for every hour he's covering, say suppose he was at his initial position 0. So because of his movement, he reaches, say suppose 1 kilometer at a time t equals to 1 hour. So let's plot this graph. Because of time 1 hour, he's moving, he is having a displacement of 1 kilometer. So because of 1 hour, he is having a displacement of 1 kilometer. This is 1 and this is 1. So he is somewhere over here. Now for the next hour, he has been displaced 2 kilometer for a time interval of 2 hours. That is, for 2 kilometer, he has a time interval of something over here. And so on. So this will keep on going. And we'll have a straight line. So this is how we can understand. We know that displacement is directly proportional to velocity. Now what is displacement and velocity? That is x equals to k into v. X equals to k into v and x by k is equal to v. And that constant k is your time t. So by this particular definition, that is, if velocity increases, displacement should also increase. That is logically correct. So if this is directly proportional and the power is to the power 1, so it should give a straight line. That is y equals to mx. We have an equation of a straight line. So if this is pointing towards equation of a straight line, so when we plot displacement and time, we should always have a straight line, and this is what is being given. This is our straight line. Now let's talk about instantaneous velocity. When you talk about instantaneous velocity, v is actually equal to limit del t when there is a very small time interval. That is del t. for a very small time interval, say suppose this is a very small time interval, what is the distance covered? What is the distance covered? So this, if I magnify this, I have a right angle triangle. See, this is a slope. This is my displacement because this is along y-axis. Along y-axis is my displacement. This is y, displacement. And along x-axis is my time. So this is a slope that I have. This is a slope. So for a very small time interval, this is actually given as del x upon del t. For a very small interval, this is velocity is dx upon dt. This del x converts to dx for a very small distance, and therefore you may have seen velocity is written as dx upon dt, which is your instantaneous velocity, and this comes from this particular derivation. Now similarly, let's talk about acceleration.